Hi everyone, this is Dr. Swaminathan SM. Now I am going to discuss about the topic called Bode plot under the frequency response analysis unit. Bode plot. So the introduction. So Bode plot, which is used to help the graph which deals with the frequency response of the system for the sinusoidal input for different frequency levels, and it is used to analyze the frequency domain from the time domain analysis, impulse response, unit step, ramp, etc. So if you give the input system and you can get the frequency domain analysis, that is sinusoidal input signal for different frequencies. Next, you can get the time domain input x of t is equal to x of sine omega t, which is given to the linear system. Then you can get the y of t is equal to beta x sine omega t plus phi. So from this you can get the frequency analysis. So what are the purpose we are using for Bode plot means? It is extracted the transfer function from time domain is difficult using differential equations. And using this frequency response, the transfer function easily obtained from the data. A system may be designed so that effects of noises are negligible. So noise is removed. Analysis and design are extended to certain nonlinear control system. So design of controller can be easily done in the frequency domain method, which is compared to the time domain method. So these are all the advantages and needs of the Bode plot. So the specifications, that is omega r, the frequency at which the system has maximum magnitude, is known as the resonant frequency. So at this, the slope of magnitude curve is 0. So the peak resonant MR, that is equal to 1 to 1.5. So it ranges from 1 to 1.5. And the cutoff frequency, the frequency at which the magnitude, that is G of j omega, is 0.707 times less than its, so the maximum value. So it is known as cutoff frequency. Bandwidth means for the feedback control system, the range of frequencies over m, that is equal to or greater than 0.707 mr. So mr is equal to 1 and bandwidth is nothing but cutoff frequency. So the bandwidth of a control system, which indicates a noise filtering characteristics of the particular system. Next, the cutoff rate, the range of slope of magnitude at cutoff frequency. Gain margin, the gain crossover, the point at which the magnitude plus cross over the 0 dB. So this is called the gain crossover frequency. So gain margin means the amount of gain that decibels can be added to the loop before the closed system it becomes unstable. The phase margin, the amount of phase shift in degrees that can be added to the loop before the closed loop system becomes unstable. So the phase crossover means the point at which the phase plot crosses over 180 degree. So these are all the different Bode plot purpose to draw the frequency response for open loop transfer function, that is OLTF, and second to find the closed loop system stability, and third to find the relative stability using gain margin and phase margin. These are all the important three purpose for the Bode plot. And next, using the Bode plot, we are defining this two plot. One is magnitude, another one is phase, using the Semilog paper, Semilog graph sheet. So the basic procedures of Bode plot means replace S is equal to j omega to convert the time domain into frequency domain. And next, write the magnitude and convert into the decibel, that is dB. Magnitude is equal to 20 log g of j omega. Next, find the phase angle, that is pi means phase angle. And next, fourth point, vary the omega angular frequency from minimum to maximum level and draw the approximate magnitude and phase plot. So these are all the important basic factors: the gain, the pole, and the multiple pole, 0 at the origin, multiple zeros at the origin, factors of the form, and first order pole on the real axis, multiple poles on the real axis, first order 0 and multiple 0 on the real axis, and quadratic poles and quadratic zeros. These are all the factors we must know. So the constant gain between greater than 1, less than 1, that is equal to 1, or between 0 to 1, we need to draw the Bode plot for constant gain k. And next, pole at origin, that makes the x-axis, that is the pole, that is the y-axis, means that is a magnitude. So to draw the different slope level for log omega, and 0 at the origin, that is the same thing. So here the y-axis is the magnitude, and x-axis is the pole, that is draw the slope for 20 plus 20 decibel the decade for the log omega. So the Bode plot of 0 at the origin j omega, and the multiple zeros at the origin. Next, symbol pole at origin. So Bode plot of the factor 1 by 1 plus j omega t for the simple pole. These are all the diagram. And next, following with the activity, we will discuss another next session for following the activity. Thank you.